Hey everyone, so I am going to demonstrate the solution that I have taken up. Before that, let me introduce myself. This is an individual participation. I am a software engineer and a TCS digital resource, and I am a part of the research and innovation team, and I am delivering solutions in the retail domain. And in the past, I have also demonstrated and given some MVP solutions that have been an accelerator for different accounts, and also I have pursued the advanced diploma from IIT Delhi on artificial intelligence and machine learning. And with that, I come up with the solution for my problem statement, that is a personalized experience to the customers. Now, whatever network we are having in DC, so particularly what I have felt that the customer recommendations or the user experience in the buyer apps like in the My Store or in the Craftsvilla or other websites that are connected to the ONDC, be it be Paytm, food ordering process, and all those things don't seem to be very fascinating. The user experience is not so fascinating. Okay. And also for validation, also I contacted with other network providers, contacted from the numbers provided in the ONDC website. I have contacted with Quaddo, My Store, and Craftsvilla contact persons. And what I felt and what the conclusions that I drew from their conversations, that they are also having the same problem and they are looking for the solutions, and there is no wholesome solution that is going to address this particular problem at this current moment of time. And so here I am with the solution that I have designed. Now basically what solution I am going to put forward before you is this. This is an architecture diagram, L1 diagram for the whole approach, and in this video I would do some board work and also demonstrate something, and parallelly I would share my POC in the form of a Jupyter notebook that I have built up here. And also for showing you the analytics part, I have also designed a Streamlit app. That Streamlit app I have also launched in this browser. So here it is. So we would explain, we would get to know as we progress. Now before that, starting from the architecture diagram, and what we see that buyer apps are connected to the ONDC framework and seller apps are on the other end. So buyers, as we consumers, are facing the buyer apps, right? So these recommendations, whatever it would be coming up, that would be showing up in this buyer app interface. So in the buyer app also, all these events get triggered. Now before proceeding to the architecture diagram, let's see how the retail giants like Amazon, they are performing on their website. See, last day I searched for some headphones and some electronic items. So see, electronic category of items are popping up, and also I checked for some apparel, and so this section is coming right related to the items you have viewed. So this what advantage this is going to give to the consumers, to the end users, right? So I am not searching it here. Rather, what I am doing, I am directly able to see what products I want, and based on my preferences or based on the customers similar to me who have same purchase habits or same interaction habits similar to me, what they are purchasing, that those things are coming up here, right? Now suppose what are these events that we are seeing here, right? Event messages, right, will be sent to the event ID, event type, customer. This data, this is the data requirement that we need, and we have a event processing microservice. This microservice will consume the data. Now what is this data? This data is the event, right? If I add something to the cart or increase the quantity, so this is update operation. Now if I add something to the cart, that is add to cart operation, right? Suppose I want to get some lighting solution, and I want to add this product. I have checked this product, and I want to add that to the cart, right? Add protection also, add to the cart. Now proceed to buy. So this is the cart. Now see, suppose I don't purchase and leave this cart as it is. So this is an abandoned cart. So that is an abandoned cart. Now if I proceed to payment, then that cart becomes a payment done cart, right? So basically I am segregating this event, whatever we are generating in the e-commerce website, into two parts, right? One is the purchased items that would be stored in the purchase history data table, where we would store those event data having the customer information, product information, store information, buyer app ID and all those informations, and the payment is done. So those records would be stored in purchase history table. And other than that, whatever events we are triggering, be it the update, merge, add or any other activity in the shopping carts of the buyer app, they are stored in the abandoned cart database. This is very vital because when the data of the customers are tracked, so it is not something that is beneficial for the customers. For the customers, don't feel I am abandoning the cart. What is it? No big deal. But it is a big deal for the e-commerce platform, because if we get to know the customer interaction, then we would be ready with the data with which we can run multiple marketing campaigns. See, here we have an interface like analytics and marketing app connected to the mailing system. We would send mails to the customer and say them that start from where you left. This is your abandoned cart. You complete the purchase. So this can be something that we are boosting the sales. Similar kind of application I have also worked upon in my previous project. So I am very much confident in this part and this approach. So this is very helpful, and this boosted the customers, the client which I delivered the project has boosted their sales to 60%. So comeback of the customers had significantly improved. Now in this approach, in this solution, what we would do, we would digest this data from the purchase history table and the abandoned cart and it would digest it by which service? Another microservice called the recommendation service. Now how it is working and what advantage it is going to bring in the buyer side apps. Now let me show you that in my board work. Now see, in the ONDC framework, this is a buyer app 1. Another app we have buyer app 2. All the apps are connected to this common protocol, and interface is ONDC protocol based on BART protocol, and we have the sellers, and we have also the seller storefronts connected to the seller apps. Okay. Now suppose I am a customer C1, my name, phone number and email ID, these things are not going to change, right? Same person will register in this buyer app, same person will register in this buyer app also. Now suppose what about I search something in Amazon, and that preferences also pop up in Flipkart, provided Flipkart and Amazon both are connected to the ONDC. Take example of my store and Capsvilla. Suppose I search something in Capsvilla and those recommendations are popping up in my store or vice versa. So all the buyer apps connected to the network can utilize this benefit of having a global object or a preference of a customer. Based on that customer ID or customer identity, we would get those interaction data and that purchase history mapped. This is going to be very beneficial to the whole network. They can easily hit a API query to the recommendation service and get those recommendations based on the products, based on the category of products that the customers are searching or they are trying to find. Okay, so everyone would be benefiting from that. This is a win-win situation for all the buyer apps, provided that they agree on the point that they are agreeing to transact the data to the services that we are going to create, and they are going to share that data among the network, because so this is going to be something new that has not happened in the whole e-commerce industry, and we have to bring something new innovative model in order to survive, and we have to beat the giants that are having monopoly in the market. So this is very beneficial for the whole network. And also the insights about the best performing products, the areas or the pin codes where the products are best performing, or the insights about the best sellers, best storefronts, all this can be accessed by the seller side, seller apps. So they are going to get that insights and they are going to benefit from that and drive the marketing campaigns. Moreover, they can also utilize the data and send some offer notifications to us, and our services will customize on that framework and send those offer data to the buyer side also. That would also help them to customize the user experience. And this data, whatever we are returning back as a recommendation, would be in the form of a JSON, right, in the JSON format, and that data would be consumed by all the buyer apps, whoever is willing to subscribing to our services, and it is their engineering and innovation how they are going to show that data in their app. So that is a competitive advantage to the buyer apps. How they are going to show up that data in the products page or in the home page, or they are utilizing that data to run the campaigns in the chatbots or WhatsApp messages in marketing campaigns, whatever they are going to do to bring the customers back to their platform and boost their sales. That is going to be a competitive advantage, and it depends how different buyer apps are going to implement that strategy. Okay, now this was the overall understanding of the approach, and see what I have done in the recommendation service. I am going to periodically read that data from the database data tables, and I would create some vectors. That vectors I would be creating with the help of LLM. In this approach, in this POC, I have used OpenAI embedding. OpenAI provides a brilliant embedding having 1536 dimensions, dimensional embedding. Now what is embedding? What is a vector space? I will also demonstrate that in the board work. Now before that, let me demonstrate this block diagram. So that vectors, whatever we are creating from the text. Now what is this text vector? Now I would create a text like this customer having these attributes have interacted with these products. So this is a text. I would create this text into a vector. Vector is nothing but a matrix of numbers, because algorithms understand numbers, language of numbers. They don't understand the language. Even if we see that the LLM models are talking with us in the form of English language or human language, human readable form, they are basically interpreting in their backend with the help of numbers, right? So that vectors we are going to generate, and we would store that in a vector DB. Now in the market there are lots of vector DB. We can also use some libraries like FAISS, or we can use Redis. MongoDB vector has recently launched. So there are a couple of options. We would store that vector in the database, and we would run the index search and get the recommendations. How we are getting the recommendations? Let's see that in the board work. Now I would show you another board work like what we are doing with the text vectors. See, suppose I have read the data from the database, and I have created a text. I have created a text. Suppose my text is like this customer A has interacted with product. This is the products. Okay. These are the products. This is my first vector. Another vector, customer B has interacted with this product. So for each of the customer profiles that we are recording in the data, in the tables, we are creating, reading, customizing that, augmenting that, and we are creating this text, and then we would use the LLM model to give us the vector embeddings. These vectors are nothing but in the space. Suppose there are some vectors in the multi-dimensional space. In OpenAI, we would get a 1536 dimensional vector. Now, if I get a query to my REST API in the recommendation service that this is the customer X, give me some recommendation of this customer. What I would do, I would first query the database and find the preferences, like customers X has interacted with these products. And then I would vector search, index search in my vector DB that give me some recommendation in or k neighbors. I would search the k nearest neighbor algorithm with the help of k nearest neighbor, like give me the k nearest neighbor to this vector. Suppose I have these vectors in the space. These are all vector v1, v2, v3, v etc. of different customers, customer A, customer B, customer C, and so on. Now my customer X preference vector is somewhat lying in this region. So I would get the nearest k neighbors. Suppose k is equals to 5 or 3. So I would get the 5 nearest neighbors, or the 5 nearest, this text I would return back, get returned, and from that I would read the products, the categories, the preferences that similar customers have liked or have interacted with. That would help us to get that recommendation. Okay. This one I have implemented in the notebook, Jupyter notebook. Now let me quickly show you the implementation in the Jupyter notebook. See what I have done. So I have stuffed the data. The data is like I have buyer IDs, I have the customer names and the customer emails. I am using 100 customers, right? User 1 to user 100. Now these customers, I have run a for loop and I have generated this event data, whatever data we are going to get in the abandoned cart data table, so that I have generated. Like the data would be like this. This is the buyer ID. From this buyer app, this request has, this event message has come. Customer name, customer email ID, the event ID means it is an update card or add to card, whatever operation it is. For simplicity, I have taken 2 events only. We can take multiple, no issue. Now in the product part, what I have done, this is the product code, SKU, whatever you can say. This is the category. This is the name of the product. This is the store ID. This is the store name, and this is the seller ID, price and quantity. So basically this is the basic information that we need for running this POC. Okay, so this is the data. So hundreds of data we have. Now after having the data, what I have done, I have created a map. I have created the map, like which customers are having which preferences. Like from this data, what I have done, I have created a dictionary. That dictionary is having the user email ID as the key and the customer product preferences as the list, as a mapping. Like I am having a customer product mapping in this dictionary. Now this dictionary, what I have got, with that I am going to generate the text that I was talking about in the demonstration in the board work. Like the format is customer ID, this email has interacted with these products. So these are the products that they have interacted. So I have created this in this list. This text have been appended in this interact text. This list seems like this one, like this email has interacted with these products. So I am creating this text. Now this text I am going to convert that into a vector. So I have hundreds of data, and now I am going to get that vector. How I am getting that vector? I have used OpenAI embedding. For that I have to install some dependencies, and with that dependencies, this is the dependency installation part, and with that I have created the vector embeddings from OpenAI embeddings, right? Creating the vector embeddings using powerful OpenAI embedding. It is very much powerful. Like I have used in couple of applications, but I feel that the embedding are brilliant and giving good results. Okay, so I have used their fake embeddings this name because first I tried with LangChain fake embedding before spending some funds from the OpenAI account. I've put some fund, and every time I invoke this query, I would some amount of money would get exhausted. So before doing that, I experimented with LangChain fake embedding, and this name is just the previous one, but I am using the actual OpenAI embeddings here. No issues. So we are getting a large vector, and we are getting a large decimal or floating point numbers. So what I did, I converted that to float 32. Okay, so after that what I did, I converted that to as a float 32 and converted that to a NumPy array. Now with that, now I am ready to store that vectors into a database. Now for database I have used FAISS, that is Facebook's library type thing, to store the dense vectors. Okay, high dimensional vectors can be stored in FAISS. So what I am doing, I am using the face CPU part, because CPU dependency, because the GPU is not so strong in my laptop, so I use the CPU. Now I am creating that index with having 1536 dimensions that I was talking about. The OpenAI use 1536 dimensional data vectors, and I am storing that in this database, FAISS vector storage. Now I am querying with these 2 samples. Like suppose I have a customer name with an email having akash@gmail.com has interacted with these products. Give me some recommendations. That recommendations, whatever we are getting, that we would get as a float vector, right? Now that vector I want to get the k samples, k nearest vectors with that vector, like that I was talking about in the board work. Like if this is my vector, what are the nearby k vectors? So from that we would get those recommendations. Now see, I got these recommendations. See here, Akash at the first the test sample was having electronics items mainly and one jeans item, clothing item. So see, the recommendation has maximum electronic items, electronic gadgets, and some jeans and clothing are also there, clothing things are there, and some minimal amount of grocery. Like these groceries things are coming because similar customers have searched with this. Now since we are getting that in a text format, now our task would be to read this data and get the customers product preferences, get the category preferences, okay, and utilize that in a JSON response and give that back to the buyer app whichever is invoking the REST API. Okay. Now once we are creating this index, we would write that and we can store that in a nearby file or in the database, right? So we don't need to run every time this embeddings part. We don't need to run. We can store that and we can easily search that and get the recommendations, right? I have stored that in this file, and from that file I am reading and I am getting the recommendation as usual. Okay. So that was the part of the recommendations that I was talking about. Now what is the benefit for the seller apps? Now the seller apps are going to utilize the APIs that we would write in the recommendation service that will give them the benefit of understanding the preferences of customers, get insights of which products are performing best, which category of products are performing best in the network, so they can boost up their inventory and the count of those products in their stores of that particular products, and they can also run campaigns, product campaigns, marketing campaigns. They can plan accordingly. So whole decision making process would be benefited from this tool. Now for that, in the notebook, see, I have used some basic PyPlot and the Seaborn SNS and all those things to get the visualization, like what are the most interacted products by the customer. So I see this is the most interacted products, and we can get the insights from that. The seller side apps, whoever is subscribing to our service as a software as a service, they can benefit from this. Like most interacted categories, what we see, the electronic product was most interacted, and you can see I have also added another thing, like which customers are having which type of interest as maximum. Like for this customer, electronic items is more interested to buy electronic goods. So I can show them more electronic items in the buyer apps, right? So this type of insight is very much helpful. I have also created a Streamlit app that is going to give that insights very easily, like this one. See, shopping cart insights, like this category is topping in the whatever data I have, this product is topping, the category is topping. So electronics item is the most purchased category. I can also see the top purchase products, other top purchase products in the network, and we can also see this data based on the store ID. Now the stores, whatever store ID, the seller apps are going to utilize this feature, and they can see which stores are having what type of customers, and they can send the emails to those customers to bring back them to the network and buy more things. They can run the ad campaigns, and also based on seller IDs also they can filter the data, like whatever store seller ID, we can get that particular data from that data storage. And we can also get some visualization, like which enterprise or which store has best performed. So that type of interaction data can also be plotted in a visualization tool. And also we can get insights about most popular sellers in the network. We can get more partnership with them. We can also have customization, like these sellers are wanting to have offers. That data would be sent to the APIs of the recommendation service, and recommendation service can send those offer data with our recommendation channel, and whatever recommendation that they are getting in the buyer app side, buyer apps can access those offers and they can show up in their websites. So this is a scope for customization also. And see, we are also getting the insights of the most popular product categories and all those things. So there are numerous possibilities, and this is a win-win situation for the buyers and the seller apps. In the whole network can grow, and we see that the whole market is going to expand, and exponentially it's going to rise. Like there was 2.5 lakhs merchants in this January, and it has surged to 3 lakhs in a couple of months. So it would surge to 3 lakhs in a couple of months based on the data what we are having the current market. So it's going to be next UPI moment in the e-commerce industry, what I also feel and resonate with the leaders, the view of the leaders of this country, and I am very happy. And so this was my overall approach, and this is my timeline that I have drafted. Like in basically, we need some developers and we need some resources who are efficient in Python programming, Java, and microservices. They will be required to build those services, build a team, and obviously we need some partnership from the buyer and the seller app side, and some other stakeholders, investors. They would help us to build the team and achieve the goals. And once we have achieved that, we would start building the microservices, whatever we have thought about, and then we would integrate with the partner systems and see how it's working, how it's getting benefited, how they are getting benefited. And once we are done with that, we would show the demo, we would create the MVP and show that demo to the network. We would also work on the feedbacks, whatever we are getting, we would refine on that, and then we would use social media marketing or content marketing or the word of mouth marketing, and all those stuff we can do for onboarding more clients. So this was my overall 6 month goal. Okay, so that was the overall approach, and I hope that I have not messed up anything. So this is the overall architecture diagram of this whole framework, and anybody can, if interested, can utilize this to boost up their sales and customer experience, user experience in the ONDC framework apps, right? Thanks for having patience, and looking forward for some communication from your end.